Hello everyone, I am Dr. Abdul Sattar Malik from the Department of Electrical Engineering, Bahauddin Zikra University, Multan. I welcome you all to a series of lectures about combinational logic of digital logic and design. In this series of lectures, initially we will have an introduction of combinational circuits, followed by the analysis procedure of combinational circuits. Then we will discuss the design procedure of combinational circuits along with some examples. After that, we will discuss some case studies of combinational circuits that will include binary adder, subtractor, decimal adder, binary multiplier, and magnitude comparator. Then we will discuss some other examples of combinational circuits that include decoders, encoders, and multiplexers along with their application. Logic circuits may be combinational or sequential. So it means there are actually two types of digital logic circuits. One is the combinational logic circuits and the other is the sequential logic circuits. A combinational logic circuits consists of logic gates whose outputs at any time are determined only from the present combination of inputs. That means the operation of the combinational circuits can be specified logically by a set of Boolean functions. It means we can express a combinational logic circuits by a set of Boolean functions. On the other hand, the sequential circuits contain storage elements in addition to logic gates. The output of the sequential circuits are a function of the inputs and the state of the storage elements. Because the state of the storage elements is a function of the previous inputs, the outputs of a sequential circuits depend not only on the present values of the inputs but also on the past inputs, and the circuit behavior must be specified by a time sequence of inputs and internal states. We will be discussing the sequential circuits in a later series of lectures. So, a combinational circuit consists of an interconnection of logic gates. These circuits react to the values at their inputs and produce the value of the output signal, transforming binary information from the given input data to a required output data. The block diagram of a combinational circuit is as shown. This is the block diagram of a combinational circuit. It contains a combinational circuit and n inputs and m outputs, where n and m can be any number. The n inputs of a combinational circuit come from an external source, and the m outputs are produced by the combinational circuit and go to an external destination. So in case of a combinational circuits, we have n inputs, m outputs, and the circuit itself, and this circuit actually transforms the binary information from n inputs to m output binary values. Each input and output variable is an analog electrical signal in actual, whose values are interpreted to be a binary signal that represents either logic 1 or logic 0. For n input variables, in case of digital logic circuits, there are a finite possible combinations, and in case of binary logic, for n inputs there are 2 raised to the power n possible input combinations. So it means n input variables can have a finite set of possible combinations. For each possible input combination of the combinational circuit, there will be one possible value for each output. Thus, a combinational circuit can be specified either with the help of a truth table that lists the output values for each combination of the input variables. A combinational circuit can also be described by m Boolean functions, one for each output variable. Each output function is expressed in terms of n input variables. There are several extensively used combinational circuits such as adders, subtractors, multipliers, comparators, decoders, encoders, multiplexers that we will be discussing in a series of lecture of combinational circuits.